Hi everyone. We are going back to week 5. I thought this might be helpful, and I had a special request for solving a trigonometric equation modeling a real-world situation. So I'm actually going to do a couple of these just so that you can kind of look at it. I think the substituting for the 2 times theta is one of the things that gets us really confused. And hopefully I'll be able to explain why we do that. So here is a particular problem that we have. Suppose a projectile is fired from a cannon with the velocity v sub 0 and angle elevation of theta. The horizontal distance r of theta it travels is given by the following formula. So we have this formula. It's given to us and will always be given to you. R of theta equals v sub 0, or our initial velocity squared, times sine of 2 theta divided by 32. So what we are going to do, the first thing that we're going to do is we are going to go ahead and we're going to plug this 80 into this, our initial velocity. So I have R of theta equal to 80 squared times sine of 2 theta over 32. Now, in your calculator, go ahead and simplify 80 squared divided by 32. So we can simplify that. 80 squared is being multiplied times sine of 2 theta. We don't know what that is yet. So we're just going to go ahead and simplify the 80 squared divided by the 32. And when we do that, 80 squared is 6,400. And 6,400 divided by 32 is 200. So I am going to have R of theta is equal to 200 times sine of 2 theta. Okay, now we are told that we want to know what we should shoot the cannon at to hit the ground 97 feet away. So here is where my cannon is. My cannon is right here. And I am going to project it up like this. And what I want to know is this horizontal distance is going to be 97 feet. So I need to know what this angle. What angle do I need to shoot that up? So that's what I'm trying to find. So our R of theta, that's going to be our 97. So the formula that I have is 97 equals 200 sine of 2 theta. Okay? So that is the formula right here that I'm really now solving. Is this 97 equals 200 sine of 2 theta. So what I'm going to do next is I'm going to divide both sides by 200, and I'm going to get 97 over 200 equals sine of 2 theta. What we need to do now is we need to do the inverse. So we're doing the inverse of sine. That's what we're doing. So we need to find the sine, or the inverse of sine, of 97 over 200. Now, this is why we substitute in the u, because we have 2 theta here. So we can't deal with that 2 theta until the end. So I think that u is what kind of confused everybody. But what we're doing here is we're trying to find the inverse of sine. We're told that the sine is 97 over 200. But we need to know the u value when the sine is 97 over 200. So on your calculator, you're going to put in 97 over 200, and you are going to find the inverse sine of that. Okay? So we are looking for the inverse sine of that. And what we get is we get this 0.5064, and that's in radians. Okay, so if we were looking at this we would be looking at something about right here. Okay, that's what we're looking at, is something about right there. Now, what we also have to be able to think about is that we need to think about it from this perspective also. Whoops. Okay, there we go. So we're looking at it from this perspective right here. So what I have to do is I have to figure out, and that's actually, I shouldn't use theta right there. I should use another angle. Just because, so let me, I'm just gonna put the value x there because I don't want us to get the thetas mixed up. So the way that I find out the angle right here is that I subtract it from pi. So remember, this is 0, this is pi over 2, and this is pi. So to find this angle, and I'm going to have two different ones, one of them is just going to be sine inverse 97 over 200 equals my u. But the other one is going to be pi minus that. And that's because of what's happening right here. Okay? So the way that I find this angle right here is I subtract it from pi. So once I find out what the angle is, I subtract it from pi and I'm good. So I'm going to put my 2 theta back. So I have sine inverse, the inverse of sine is 97 over 200, and that is going to equal my 2 theta. So I can put that 2 theta back. But I've also got to deal with this angle right here. I'm going to deal with that angle right there. So I've got to have, so my second one is going to be pi minus sine inverse of 97 over 200 equals 2 theta. So I can have either one of these. Either one of these can be my answer. So at this point, what I'm going to do is I am going to solve. I'm going to solve this now. So to get rid of, so I've got two different equations that I'm solving. My first one is sine inverse of 97 over 200 equals 2 times theta. Okay. What I can do here is I can multiply both sides by 1/2. And the reason I'm multiplying both sides by 1/2 is because I can cancel out that 2 right there. So then I'm just left with theta. And so I have 1/2 times sine inverse of 97 over 200 equals theta. That's our first one. So when I do my calculator and I do 1/2 times, I would encourage you to put this in parentheses right here in your calculator. Put all that in parentheses. 1/2 times that is going to be 0.25. And remember, we're talking in radians. So one of our angles that we can shoot the cannon off at is 0.25 radians. And remember, we're talking about radians. Okay? Now the other one, we are going to have pi minus that. So let me rewrite this so that we can be sure that we understand what's going on here. I've got pi minus sine inverse of 97 over 200 equals 2 times theta. Now remember, we just multiplied the other one times 1/2. So that's what we're going to do right here. We're going to multiply this times 1/2, and we're going to multiply all of this times 1/2. Okay? So theta is going to be 1/2 times pi minus sine inverse of 97 over 200. Now, if it's easier for you to think about this, you certainly could do you could take the inverse, and I know it tells us not to round until the very end, but we already know the inverse sine of 97 over 200 is approximately 0.5064. So remember, that's what we're talking about here. When I'm subtracting the sine inverse of 97 over 200, I'm subtracting an angle measurement that is about approximately 0.5064 radians. It's approximate. Now we did some rounding, and so that's what it is. But that's what you're doing. Now we're gonna do exact, but essentially I'm saying 1/2 times 3.14. That's an approximation, but that's what we're doing. Minus 0.5064, and that's approximation. But I want you to kind of put those numbers there so you can realize what we're doing. Now, when I do the keystrokes in my calculator, okay, you're going to have to do some pretty intense keystrokes in there to make sure that you get this correct. So when you do that, I would do 1/2. I would do brackets, and I would hit my pi, and then I would hit minus. I'd go ahead and put sine inverse in parentheses. You may even end up with another set of parentheses here. Okay, so you're looking at having 2 parentheses and then another set of brackets. So what I'm doing here when I'm talking about and putting this very specifically in my calculator, I'm making sure my calculator follows order of operations. And when I do pi minus the inverse of sine 97 over 200, and then I multiply that times 1/2, my other theta is going to be 1.32, and we're still talking about radians. Now, I know that second one this second one right here is the one that's confusing. So let's go back and let's do it with the numbers. Okay, so we've got our 1/2. Okay, we know that pi is approximately 3.14, and we know that the sine inverse of 97 over 200 is approximately 0.5064. Okay, so if I do 3.14, and remember, we're still talking about approximations here, so it's better to do it and not round until the very end. But if this helps you to think about it, then I think it's okay to look at it this way. So when I do 3.14 minus 0.5064, I get 2.63336. Then I'm dividing by 2, but dividing by 2 is the same thing as multiplying by 1/2. I get that theta equals 1.32 radians. So remember, when I'm talking about the inverse of sine, I'm just talking about a number. I'm talking about an angle measurement. Okay? So hopefully this one will get you started, and then I'll be back in a few minutes with another one.